All right, for our last real problem in this section right here and the chapter, is kind of a culmination problem a little bit. And it's a problem that's going to have you go back and look at your identity sheet to see if we can start to figure out what we can do. So there's two things on this particular problem I want you to stick around for. The first one is I want us to anticipate, based on what we see, maybe where this is going to go. And I don't blame you one bit if you can't see it right now. In fact, I couldn't see it right now the first 1, 2, 20 times I've done this problem or problems like that. But with time, with messing up, with failure, with trial and error, I start to kind of figure out what we can do. So one thing that we can do with this problem is let's square both sides. I know you're asking, where in the world did that come from? I get it. But just sit back and watch. Square both sides. The right side just becomes a 1. Let's do this side. That becomes a sine squared. X minus a 2 sine x. Cosine x minus plus a cosine squared x equals a 1. I'm going to put the sine squared of x plus the cosine squared of x minus the 2 sine of x cosine of x equals a 1. All right, I'm going to stop and let you catch your breath here. Sine squared of x plus cosine squared of x. Aha! If I remember, that equals a 1. All right, Willie, still doesn't look like it's much better than what we started with. That certainly looks better. Let's subtract 1 from both sides. Let's divide both sides by a negative 2. All right, maybe that looks a little better. We know this is true when sine of x equals 0 or when cosine of x equals 0. So let's find out and see if we can remember where are my values of x when that equals 0. So sine of x equals 0 when x equals 0 or x equals pi. Cosine of x equals 0 when x equals pi halves or when x equals 3 halves pi. Again, those were one of the 16 original angles that we were spending some time to kind of memorize because we use those all of the time. So those are my 4 values or my 4 solutions to this particular equation. However, I did ask you to stick around. The reason why I asked you to stick around is maybe you remembered from the depths of your mind that anytime you raised an equation to an even index, you had the possibility of introducing extraneous solutions. So that means I need to make sure that each of those solutions is true. So I need to check them. So let's look at our original equation. Sine of x minus the cosine of x equals 1. And let's just check each of those solutions that we have. So let's check for x equals 0. Sine of 0 minus the cosine of 0. Does that equal 1? Well, the sine of 0 is 0 minus the cosine of 0, which was a 1. Does negative 1 equal 1? It does not. So this is not a solution. Let's try where x equals pi. So the sine of pi minus the cosine of pi equals a 1. Is that true? Sine of pi equals a 0 minus the cosine of pi. Cosine of pi was a negative 1. Does that equal 1? Yes, minus and minus 1, 1 equals 1. So there's one solution so far. Let's keep testing these. Let's try x equals pi halves. So sine of pi halves minus the cosine of pi halves. Does that equal 1? Sine of pi halves was a 1. Cosine of pi halves is a 0. 1 does equal 0, or 1 minus 1 equals 0, if that is true. So there's a solution. And let's try the last one. Sine of 3/2 pi minus the cosine of 3/2 pi. Does that equal 1? Sine of 3/2 pi was a -1 minus the cosine of 3/2 pi, which was a 0. Minus 1 minus a 0, -1 equals 1. That is not a solution. So that is not a solution. So out of my 4 possible solutions, we found that 2 were extraneous and 2 indeed were correct solutions. That wraps up this section. Have a great time practicing, and I hope this was helpful.